Hey everyone, and welcome to This Explainer. Today we're unpacking something pretty amazing, the invisible engines that are quite literally running the automated world all around us. We're talking about the Arduino brain. We're going to explore exactly how microcontrollers act as the essential electronic brain for modern robots, basically giving completely inanimate objects the ability to process information autonomously. It's a fascinating journey, going from basic nuts and bolts hardware all the way to automated decision-making. So to really get why this technology is a complete game changer, imagine this for a second. What if you had to tell your legs exactly how many millimeters to move every single time you took a step, right? Like forward 50 millimeters, elevate 30 millimeters, tilt foot down. Honestly, you'd be completely exhausted before you even made it out of your bedroom. Well, humans don't have to do this because our brains handle all those crazy calculations autonomously, right in the background. And robots? They face the exact same problem. They absolutely need that autonomy to function without constant, exhausting human input dictating every tiny little millimeter of movement. All right, let's jump right into section 1. Meet the microbrain, the engine of autonomy. Okay, let's dive into this. A microcontroller is basically the essential electronic brain that enables robots to function autonomously and actually make automated decisions. Think of it like a tiny, self-contained computer situated right there on a single integrated circuit chip. When we talk about a robot thinking, we're really just talking about the microcontroller doing its job. It's that crucial piece of hardware sitting right in the center of a machine, managing the flow of information and allowing a device to operate entirely independently of a human operator. Now, there's a really common misconception out there about these processors. When people think of a robot's brain, they almost always imagine this massive, high-powered gaming computer doing billions of complex calculations every single second. But in reality, microcontrollers are incredibly specialized and they use very low power. Unlike your typical PC processor that's meant to run heavy, general applications like web browsers or high-end video games, microcontrollers are, well, they're elegant, efficient little engines. They're specifically designed to do precise, automated tasks incredibly well, and they do it without draining a massive power supply.
Moving along to section 2, the logic of robotics and how we translate data into mechanical actions. So the fundamental process flow of all robotics basically boils down to 3 really elegant steps. It always starts with an input. This is your sensors collecting data from the physical world, things like temperature, light, or distance. Then, that data travels to step 2, the microcontroller, our brain, which processes the information based on whatever code it was given. And finally, step 3, it triggers an output. It translates that data into a mechanical action, like sending a quick signal to a motor or a light to actually do something in the physical world. So it's just input, brain, output. That's the whole loop.
Let's put this into practice for a second. If you wanted a robot to turn on a light when it gets dark, which part of our model is the input? Well, the input has to be the device sensing the environment, right? So in this case, it's a light sensor detecting the absence of light. That sensor tells the microcontroller, hey, it's dark out here. And the microcontroller subsequently triggers the output to switch the bulb on. That simple logical flow, that is the absolute foundation of all automated robotics. Section 3, the Arduino origin story, or smart machines for everyone. This is a really cool backstory because the Arduino microcontroller perfectly illustrates the power of accessible tech. It wasn't cooked up in some secretive multi-billion-dollar corporate lab. It was actually created in Italy by the Arduino team with a very specific and honestly pretty noble goal. They just wanted a low-cost tool so that students everywhere could build smart machines. Because before Arduino, programming robotic intelligence meant you needed super expensive equipment and, elite engineering degrees. Arduino completely democratized the hardware. Suddenly, everyday people, hobbyists, and regular students could afford to experiment with automated decision-making. It was a real game changer. All right, section 4, programming your first circuit and getting hands-on with the hardware. Now, you might be thinking you need thousands of lines of code to build your first intelligent circuit, but you really don't. It literally starts by just identifying the specific input and output pins on your little Arduino Uno board. Then, step 2, you just connect a simple LED light to those pins. And finally, step 3, you write a super basic blink code. All you're doing is instructing the brain to toggle the power to that LED on and off in a continuous loop. It completely shatters this myth that robotics has to be overwhelmingly complex to get started. Of course, making that simple blink code work does rely on mastering just a few essential hardware basics. You've got to understand pin functions, basically knowing which pins receive sensor data and which ones are sending out motor commands. You also have to balance power requirements, making sure your specialized brain is drawing just the right amount of electricity so you don't fry it. And finally, you need to understand LED circuit integration to actually close the physical loop of electricity so your output can happen. But once you have those few basics down, you unlock pretty much everything.
And that brings us to Section 5, Real-World Robot Logic, Scaling the Blank.
Here's where the concept truly scales, and it's kind of mind-blowing. We can map the exact same simple blink code logic we just talked about directly to an automated real-world lighthouse. Think about it for a second. An LED blinking on your desk every 5 seconds uses the exact same process flow model, the exact same logical loop, as a massive, life-saving lighthouse beaming light out to sea every 5 seconds. The hardware output is just way bigger. You're basically just swapping out a tiny desk light for a massive, high-powered bulb. But the microcontroller's logic, it remains exactly the same.
So, to tie this whole shebang together, the specialized brain, our trusty microcontroller, is what directly enables automated decision-making. That is the absolutely crucial takeaway from this entire explainer today. We aren't just figuring out how to turn on lights, we are getting inanimate objects the ability to interpret data from sensors and autonomously choose an action. We are creating intelligent features that make our world smarter, safer, and entirely automated.
Before we wrap up, I want to leave you with a really fun reflection drawn straight from our source material today. What if you could give your backpack a brain? What would you program it to do? Maybe it senses the weather and automatically deploys a rain cover. Or maybe it senses its own weight and alerts you if you're carrying way too many heavy textbooks. The logic of inputs, microcontrollers, and outputs makes all of that entirely possible. Our world is literally full of objects just waiting for a brain. So, what will you automate next? Thanks so much for joining me for this explainer. Keep exploring, and I'll catch you next time.